Hello, in this video we're going to look at solving absolute value inequalities, which is very similar to solving radical inequalities in that we are going to solve the associated equation and then figure out which intervals are part of the solution and which are not. Now, the tricky thing about absolute value inequalities is we're finding two sets of critical values. So first off, when I'm solving the absolute value equation, I need to use the critical values defined by the argument of the absolute value in order to figure out the two different cases or the three different cases and solve the equations. Once I've solved the equation, then I have those new critical values to use for my test intervals. So let's start by solving the equation, the absolute value of x minus 2 equals 5. So the critical value for this equation is when is x minus 2 equal to 0? So that is at 2. On one side of the 2, so when x is less than 2, x minus 2 is going to be less than 0, which means the absolute value of x minus 2 equals opposite of x minus 2. And this is case 1. Case 2 is going to be when x is greater than or equal to 2, and that is when x minus 2 is greater than or equal to 0, which means that the absolute value of x minus 2 just is x minus 2, so this is case 2. So in case 1, my equation is the opposite of x minus 2 equals 5. Or in other words, I could say x minus 2 equals negative 5, so x equals negative 3. Negative 3 is less than 2, so that is in the domain, so that is an acceptable answer. It's not an extraneous root. In the second case, I just have x minus 2 equals 5, which means x equals 7. X equals 7 is greater than or equal to 2, so that is also in the appropriate domain. So these are the solutions to the equation. Absolute value of x minus 2 equals 5. This now means I can return to my inequality and use these two values to define intervals, negative 3 and 7. Negative 3 and 7 are going to be solutions to this inequality because I'm allowing for it to be less than or equal to 5. And these are the values where it is equal. And now I just test a value inside of each of these intervals. So let's say, for example, x equals negative 10, x equals 0, and x equals 10. These are the solutions or the values I'm choosing to test. You can pick any number that is less than negative 3, any number between negative 3 and 7, and any number greater than 7. So is the absolute value of negative 10 minus 2, which is the absolute value of negative 12, which is 12, 12 is not less than or equal to 5. So this interval is not included in my solution. I go into the middle. When x equals 0, I have the absolute value of 0 minus 2, which is the absolute value of negative 2, which is 2. 2 is less than or equal to 5, so this interval is included. So at the very least, I have all of these values. Testing the last interval then, absolute value of 10 minus 2, well, that's the absolute value of 8, which just is 8. 8 is not less than or equal to 5. So this interval is also not going to be included. So my solution interval is just negative 3 to 7. And again, the negative 3 and the 7 are included in the solution. So that's the basic idea here. Now, obviously, as our inequalities get a little more complicated, as our absolute value equations get a little more complicated, this can take a few more steps. But we start by solving the absolute value of x plus 3 equals the absolute value of x minus 4. So I've got cases here. I've got two critical values. I've got negative 3 and 4. So if x is less than negative 3, then x plus 3 is less than 0, and x minus 4 is less than 0. So that's case 1. If x is between negative 3 and 4, then x plus 3 is going to now be greater than 0, but x minus 4 is still going to be less than 0. And if x is greater than 4, then these are both going to be positive. So x plus 3 is greater than 0, x minus 4 is now greater than 0. So these are my three cases. So in case 1, I have x plus 3 is the opposite of x plus 3 is equal to the opposite of x minus 4, which is just the same as x plus 3 equals x plus 4, which if we're paying attention, this is just case 3. So case 1 and 3 are basically the same. So this is case 1 and 3. So either they're both opposites or they're both the same, in which case the equation is the same. But in either case, what I end up with is a statement that simply isn't true. So I end up with the statement 3 equals 4, which it obviously isn't. So there are no solutions that fall in either x is less than negative 3 or x is greater than 4. In case 2, I've got x plus 3 is greater than 0, so x plus 3 is just going to be x plus 3, but I need the opposite of x minus 4. So this is the equation x plus 3 equals negative x plus 4. So 2x equals 1, which means x equals 1 half. 1 half is between negative 3 and 4, so this is an acceptable solution. And this means that for my inequality, I have only one critical value. That is 1 half. And 1 half is not actually part of the solution because I want to know when is the absolute value of x plus 3 less than the absolute value of x minus 4, not equal to. So now I'm going to test a value on either side of 1 half. So let's say when x equals 0, or when x equals, let's say, 7. So is the absolute value of 0 plus 3 less than the absolute value of 0 minus 4? Well, 3 is less than 4. So yes, that is true. Is the absolute value of 7 plus 4 less than the absolute value of 7 plus 3 less than the absolute value of 7 minus 4? Well, 10 is not less than 3. So this interval is unknown, which means that the solutions to this inequality are the values of x that are less than 1 half. In interval notation, x belongs to the interval from negative infinity to 1 half. And finally, let's look at another inequality with two absolute values. So again, we're going to solve the associated equation first. So when is the absolute value of x plus 2 plus the absolute value of x minus 1 equal to 3? So we've got 3 cases that are going to show up here. We've got critical values at negative 2 and 1. So case 1 is going to be, they're both negative. So x plus 2 is less than 0 and x minus 1 is less than 0. In case 2, x plus 2 is going to be greater than 0, but x minus 1 is still less than 0. And in case 3, they are both going to be greater than 0. So my 3 equations that I have to solve. Equation 1, this is for the domain x is less than negative 2. So I'm solving the opposite of x plus 2 plus the opposite, so in other words minus x minus 1 equals 3. So negative x minus 2 minus x plus 1 equals 3, which means negative 2x equals 4. So x equals negative 2. Ooh, interesting, because this is the boundary point. Now, technically, I haven't included the negative 2 in this interval. You may have included the negative 2 in this interval, in which case you would accept it here, but I'm not going to accept it here. Don't worry, it'll show up again in the second case. But negative 2 is not less than negative 2, so I'm not going to include it at this point. Case 2, this is where x plus 2 is positive, but I still have to do the opposite of x minus 1. This is the interval where x is between, so now I'm going to include the 2. So the negative 2. Negative 2 is less than or equal to, x is less than or equal to 1. So let's call that the domain for this one. So this is x plus 2 minus x plus 1 equals 3. This is a case where everything cancels, but instead of ending up with a false statement, I end up with a true statement. 3 equals 3. So this means every solution or every number in the interval, so every x in the interval from -2 to 1 is a solution. So those are all solutions to this equation. Now, being careful, they are not solutions to the inequality. But the endpoints, -2 and 1, are going to be critical values. Case 3, they're both positive. So x plus 2 plus x minus 1 equals 3, which means 2x equals 2, x equals 1. This, for me, is my interval x is greater than 1. So 1 is not included in that interval, but it's okay because I've already included it in the previous interval. So my only critical values here are still -2 and 1. So actually, the turning points for the absolute values are also the critical values for this inequality. So I've got -2 and 1. Now, I already know what's going to happen if I pick a number between -2 and 1. If I pick x equals 0, for example. I already know that at that point, it's going to be equal to 3. And I don't actually want it to be equal to 3. So in this point, I've got the absolute value of 0 plus 2 plus the absolute value of 0 minus 1. That equals 3. And that would be true no matter what number I picked between -2 and 1. It's always going to be equal. And since I don't want to include equals, I can't include this interval. I also can't include the endpoints, because if I chose the endpoints, they would also be equal to 3. If you substitute -2 in here, or if you substitute 1 in here, you get equals 3, which I don't want. So now what I'm left to determine is, are either of the other intervals included? So let's choose if x equals, say, -5. So the absolute value of -5 plus 2 plus the absolute value of -5 minus 1. This is 3 plus 6, which is greater than 3. So I can include this interval. And let's say if x equals 7, is the absolute value of 7 plus 2 plus the absolute value of 7 minus 1 greater than 3? Well, this is 9 plus 6, which is, yes, greater than 3. So I can include both of these intervals. If they didn't work, I would have no solutions. This inequality would have no solutions at all, but they do work. So x can belong to the interval from -infinity to -2, or from 1 to infinity.